the next theorem or the property of outer measurable set. So what it states? We are doing the Lebesgue measurable sets and its properties. Right? So today's theorem or the next property is, let A be any set and E1, E2 shown up to En, a finite sequence of disjoint measurable sets. Then, what do we want to prove? The outer measure of the set A intersection union I running from 1 to n ei is equal to summation I running from 1 to n m star A intersection ei. This we want to. यानी A इंटरसेक्शन यूनियन ये एक सेट है, इसका मेजर किसमें कन्वर्ट हो गया? यूनियन इज कन्वर्टेड इनटू समेशन एंड वी आर लेफ्ट विद द मेजर ऑफ इफ A intersection EI, right? So we will start the proof. So from where we will start? Jahan I running from 1 to n, it means we will apply mathematical induction. We shall prove the result by principle of mathematical induction on n, right? For n is equal to 1, when I will put n is equal to 1, जब आप n is equal to 1 लगाएंगे तो m a intersection एक ही सेट रह गया, राइट? तो यहाँ पे क्या आ गया? E1 समेशन आई किस में बदल गया? एक में ही, तो m स्टार a इंटरसेक्शन E1 इज इक्वल टू m स्टार a इंटरसेक्शन. कुछ नहीं किया मैंने, यूनियन, इट वाज यूनियन ऑफ n. Now if n is equal to 1, it means you have only one set, that is E1. So this becomes m star a intersection E1. This is a summation of n items, but now we will have only a single value, your single set. It implies ये summation बीच में से निकल जाएगा. This becomes m star a intersection E1. So both values are equal to. Therefore, the result is true for n is equal to 1, right? Let us assume that. Let us assume the result is true for n is equal to k, then we will prove the result for n is equal to k plus 1. Or we can say that let's the result is true for n minus 1, then we will prove the result for is equal to n. So anyway, you can do this question. So assume that this is a step number 2. That was a step number 1. Step number 2, assume that the result is true for n minus 1. It implies m star a intersection union कहाँ तक जाएगा? I running from n minus 1. Here we have ei. This is equal to summation I running from 1 to n minus 1 m star a intersection ei. Right? Step number 3. To prove the result for n. So taking B is equal to A intersection union I running from 1 to n ei, right? Ei on taking. So why we have taken B beta जी? B क्यों ले लिया? It means इससे पहले एक step हमारे पास आएगा. Since each En is measurable, it implies for any set B, m star b, मेजरेबिलिटी की कंडीशन लगा देंगे, m star b इंटरसेक्शन en plus m star b intersection en complement for all b contained in R. Now this we will take this b as, ये जो हमने टेस्ट सेट है हमने b assume किया है. Now we will put in star. इसको हमने देंगे स्टार में, इसको पुट कर देंगे, राइट. So it implies what we will have. यहाँ पे था m star a intersection union I running from 1 to n ei, right? ये b की वैल्यू एक यहाँ पे पुट हो गई. Then we have m star a intersection union I running from 1 to n ei, right? यहाँ पर ये b की वैल्यू पुट की, इंटरसेक्शन साथ में कौन आएगा, en प्लस m star a intersection union I running from 1 to n ei intersection en complement, right? अब हम वन बाय वन इनको सॉल्व करेंगे, राइट. इसको पहले इस एक्सप्रेशन को सॉल्व करेंगे, फिर हम इस एक्सप्रेशन को सॉल्व करेंगे. लेट इट बी नंबर 3. नाउ सिंस all ei's are disjoint, all ei's are disjoint, इसका मतलब इंटरसेक्शन I running from 1 to n ei is equal to क्या आना चाहिए, 5 आना चाहिए. So now consider union I running from 1 to n ei intersection en. So this is equal to E1 union E2 union so on up to union En intersection En. It means E1 की intersection En के साथ. It means E2 intersection with En so on up to En intersection En. So हमने कहा सारे सेट्स क्या हैं, डिसजॉइंट है. बस En के इंटरसेक्शन इसके साथ क्या आएगी, En, और यूनियन किसके बराबर आएगी, En. इट मींस ये वाला जो सारा सेट है दिस वन, ये किस में कन्वर्ट हो गया, En में, राइट. उसी तरह अब हम करेंगे. नाउ we will consider union I running from 1 to n ei intersection En complement. अब आप नेक्स्ट स्टेप में लिखेंगे, आई एम डूइंग हियर, आई हैव टेकन हियर यूनियन आई रनिंग फ्रॉम 1 टू n ei इंटरसेक्शन en कॉम्प्लीमेंट. तो यहाँ मेरा आ रहा है E1 इंटरसेक्शन en कॉम्प्लीमेंट en कॉम्प्लीमेंट. सो E1 इंटरसेक्शन en, बस यहाँ से एक स्टेप चेंज होगा. So E1 intersection En, this is equal to E1. This is E2. सिर्फ En और En intersection जो है that will be equal to 5, right? और union कहाँ तक आएगा, ये union En minus 1 तक जाएगा. So this becomes union I running from 1 to n minus 1 ei. It means ये वाला जो सारा portion है ये किस में convert हो गया, union I running from 1 to n ei, right? So the question is here, if while E1 intersection En complement is equal to E1, definitely बेटा E1 En complement में सारे ही आ जाएंगे आपके पास, ठीक है. अगर ये सेट की बात करें, ये देखो, ये अगर आपके पास वेन डायग्राम बनाए तो you have so many set E1 E2, ये सारे क्या हैं, आपस में डिसजॉइंट है. इसमें से अगर मेरा ये E1 है और En का कॉम्प्लीमेंट, और अगर ये मेरा इसमें से En है, तो En का कॉम्प्लीमेंट ये सारा हिस्सा बनेगा. तो डेफिनेटली छोटा कौन है, छोटा आपके पास आ जाएगा E1. So that why the intersection will have E1. Here the intersection will have E2. Now we will put all these values in number 3. Therefore 3 implies M star A intersection union I running from 1 to n ei. This is equal to, first becomes A intersection En, and the second becomes A intersection union I running from 1 to n minus 1 EI. So this is equal to M star A intersection En plus, and the result is true for what? For n minus 1. So this becomes summation I running from n minus 1 M star A intersection EI by step 2. ठीक है जी, बाय स्टेप नंबर 2. अब ये n-1 तक समेशन है, उसमें एक और जोड़ दिया, इसको इकट्ठा कर लीजिए. समेशन आई रनिंग फ्रॉम 1 to n m स्टार a इंटरसेक्शन en. देखो ये n-1 तक की सम है, ये इसमें एक और एडअप हो गया. सो वी हैव प्रूव दैट द रिजल्ट इज ट्रू फॉर n. Result is true for n. So hence by principle of mathematical induction, this result here is m star a intersection union I running from 1 to n ei. Therefore last में आप क्या लिखेंगे? Therefore by principle of mathematical induction, the result is true for all n belongs to n. The result is true for all n belongs to n. That's all, right? Now we will come to the next theorem or next property of measurable set in terms of theorem. If E1, E2 soon up to En is a finite sequence of disjoint measurable sets, then M of union I running from 1 to n ei. This is equal to summation I running from 1 to n measure of ei. This we want to do. So this will only hold if it is a finite sequence and it is disjoint measurable set. So again we have, and we will prove it by method of principle of mathematical induction. Let's come to its proof. So again we shall prove that we will apply induction on it. We will apply induction on n. Similarly, clearly the result is true for n is equal to 1. I will not prove it clearly. I will just write, this is step number 1. Clearly the result is true for n is equal. क्योंकि अब आप जब आप मेजर यहाँ पे पुट करेंगे, when you will put n is equal to 1, मतलब रह गया measure of E1, यहाँ भी रह गया measure of E1. So clearly result is true for n is equal to 1. Assume that, step number 2. Assume that the result is true for n minus 1. You will write here, assume that the result is true for n minus 1. That is union I running from 1 to n en minus 1. En minus 1 is measurable. Before applying the induction on this, first of all, what we will prove that union I running from 1 to n ei is measurable. पहले हमारा जो पहला स्टेप है, पहले हम ये प्रूव करेंगे कि ये जो सेट जिसका मेजर निकाल रहे हैं वो मेजरेबल है. So on this we will apply principle of mathematical induction. So when I will take n is equal to 1, the result is true because E1, E2, E3 all are measurable sets. So therefore E1 is a measurable set. Now step number 2, we will assume that the result is true for n minus 1. It implies union I running from 1 to n minus 1, en minus 1. Sorry, here is union I running from 1 to, here you will write en minus 1, here you will write e. Ei is measurable, right? अब हमें prove करना है, we will prove the result. Now you will write the step number 3. Prove the result for n. So union I running from 1 to n ei आप consider करेंगे. You will split it 1 to n minus 1 ei union en, right? Let it be e dash union en. This is the union of two measurable set. Union of two measurable sets. It implies a measurable set. A measurable sets. It implies union I running from 1 to n ei. ये क्यों आया? By step number 1 and 2. So union I running from 1 to n is a measurable set. Is a measurable set, right? So by principle of mathematical induction, the result is true for n, hence it is true for all n natural numbers. So हमने ये prove कर दिया कि this is measurable set for all n belongs to n, right? Therefore, अब आगे चलेंगे. So it implies अगर अब union जो है वो measurable हमारे पास set है, so therefore it implies अब हमने क्या प्रूव कर दिया? यूनियन I running from 1 to n ei क्या है? Is a measurable set. Or we have already discussed that if E is a Lebesgue measurable set, अगर E क्या है? Lebesgue measurable है, then the measure of E is equal to outer measure of E. ठीक है जी? Same here. It implies measure of union I running from 1 to n ei, right? This is equal to m star union I running from 1 to n ei. ये हमारे पास आ गया. ठीक है जी? Let it be number 1. So since all E1, E2, En are disjoint measurable sets, all क्या है? Disjoint. They all are disjoint measurable sets. Therefore, for any set, हम testing set ले लेंगे contained in R, we have already proved that A intersection union I running from 1 to n ei. ठीक है जी? This is equal to summation I running from 1 to n m star A intersection ei. Right? Let us take A is equal to capital R. अब मैं इसकी जगह पे आप you will write the next step. इसी पे ही मैंने क्या कर दिया? R कर दिया. ठीक है? और जब आप R करेंगे, R तो यूनिवर्सल सेट है, तो इसकी इंटरसेक्शन में यहाँ से ये बचेगा, यहाँ से ये आएगा. It implies m star union I running from 1 to n ei. This is equal to summation I running from 1 to n m star ei, right? Clear? Because every ei is contained in R. For all I, it implies union I running from 1 to n ei is contained in R. So what is the result you want to prove that? अब हमने prove कर दिया अभी union measurable था, it is a Lebesgue measurable set and the Lebesgue measure is equal to outer measure. So here we will change m of union I running from 1 to n ei. This is equal to summation I running from 1 to n m of ei, right? Because ei is measurable. Therefore, m star ei, yeah, m of ei is equal to m star ei. So this we want to prove. In order to prove this, first of all, the theorem starts from कि this set is, ये वाला जो set है, this set is measurable. सबसे पहले हमने ये प्रूव किया कि ये वाला सेट मेजरेबल है. मेजरेबल प्रूव करने के बाद what we have done, we have written the Lebesgue measure of this set is equal to outer measure. Now all EIs are disjoint measurable sets. So we have used that previous theorem A intersection union I running from 1 to n, वो theorem use की, then we will take the test set A as is equal to R. R is a universal set. Its intersection will give the smallest set. So in here we have got the smallest union. Here we have got EI. In the last we have the outer measure. Outer measure is equal to Lebesgue measure because ये sets क्या हैं, measurable. So that's all about this property, or you can say the